Hi, I'm Yves, co-founder and CTO of Deontic, and today I'm going to show you how we use generative AI to create driving scenarios and the corresponding simulation files to help automotive engineers speed up their validation process. So let's start with a simple scenario. For example, a car drives on a straight road at 50 kilometers per hour. Our platform is going to take natural language input like this and suggest a draft scenario based on it. So here to the left, we see this draft scenario. We see that our platform suggests a road network with one road of 550 meters and two lanes. It positions one road user on this road, a car that is driving at 50 kilometers per hour, exactly like we asked. To the right, we can generate a video to validate whether this is a scenario that we had in mind. And if we're happy with the result, we can immediately download the OpenDrive and the OpenScenario files and import them in a wide range of simulation software. However, we can also give feedback on this scenario to update it or to make it more elaborate. For example, we can ask the platform to add a driving lane on either side of the road. And in this case, the software is going to take both the draft scenario and our feedback, and it's going to combine them into a new draft scenario. So here we get the same scenario as before, with a single difference that now a driving lane has been added to both sides of the road. The ego vehicle is still there, it's still driving in lane 1, and it is still driving at 50 kilometers per hour. Let's generate a video to validate this and see if this looks correct, which it does indeed. Now let's make this scenario a bit more elaborate. Let's say that we add another vehicle in the same lane, 50 meters in front of ego, and it's driving more slowly. So let's ask our software to update the draft scenario in this way. And now to the left, hopefully we can see a draft scenario that not only has the same road network, but two road users instead of one. And we see indeed that this is the case. There is not just ego vehicle, but also another vehicle in the same lane, driving more slowly at 30 kilometers per hour to be precise. So let's generate the video to take a look. Now we have these two vehicles in the same lane. And of course, because the ego vehicle is driving faster than the other vehicle, it's going to crash into this vehicle. So let's ask for a final update to avoid this crash. So let's ask the method, or let's ask the software to have the ego vehicle slow down to the speed of the other vehicle when it comes within, say, 30 meters of the other vehicle. In this case, our platform is going to again take the draft scenario and add a first maneuver to this draft scenario. So we see now that there is a maneuver. The ego vehicle will decelerate from 50 to 30 kilometers per hour at the right time. Let's generate the video again and see if this is indeed what we had in mind. So the ego vehicle is approaching the other vehicle, but at the right time it's going to slow down, and as you'll see, it doesn't crash into the other vehicle anymore. So this was a quick look into how our software takes natural language input, converts it to a driving scenario, and then converts it to the simulation files for this driving scenario. But our platform can do more than that. You can upload documents with requirements, extract those requirements, generate scenarios on the basis of those requirements, and so on. If you'd like to try this out for yourself, go to our website to test out our public demo, or ask for access to our platform.